So my name is Lionel, and I'm one of the lead dev at Veepee. I work with the sourcing, sales preparation tribe in the offer management team, and I work a lot with JavaScript, React, .NET, a bit of F Sharp, C Sharp. So I have the opportunity to work with different technologies. So here I'm going to introduce you one way of designing the fronts using the, the paradigm of reactive programming. So can you go on the, thank you. Reactive programming. So here I'm going to talk about the reactive programming and how to design the GUI, because the question about designing the user interface is how do you think, how do you document the technical issue, the code, how do you document the technical issue you are going to develop when you develop some front feature, because the front isn't only about the developing mockups, it's also about other stuff. So I'm going to see it in this presentation. Can you go on the right, please? Okay. A few months ago, my nephew, that's him, he asked me the question, what is programming? So I told him that it's not my job, but that is part of my job. And still, it's a very interesting question. So go down. Can you go down, please? Yes, I went to Wikipedia to search like the definition of computer programming. So I found this. So the process of designing and building executable computer program to accomplish a specific computing results. The issue here is, okay, this is true, but it's not clear enough. It wasn't clear enough. So I tried to find my own metaphor, my own definition to give it to someone who doesn't understand anything about all of this. So can you go down again? So I gave this definition. Programming is like writing recipes for computers. So it means, actually, for those who does the same job as I do, programming is like writing instruction. And that's basically what a recipe is a set of instruction to perform a specific task. Can you go down again? So I decided to give an example of that. This is a recipe, and I wrote it like it was code. So basically, for everyone who already done some code, whatever is JavaScript, C#, Java, anything, you can recognize this. And for anybody who has never written any code, it's still readable for you. So this is basically code. If you can read this, it means it's possible to write code anybody can read, because this is basically the type of stuff we write when we do code. But still, I felt that this wasn't like the perfect metaphor, because this doesn't work in every case. So can you go down, please? So here we have like, I felt like an issue. You won't see it like right now, but when I write my recipe, nothing tells me in which situation the recipe is going to be used. So it means like I write the recipe, I don't know if it's going ever to be used. I know that it's available. Okay, it's a set of instruction, it's available. I don't know when it's going to be used. I don't even know if it's useful. Can you go down again? So I try to imagine another metaphor. Let's say you have a driver who is asking for his way to going from Place de la République to Place de la Bastille. If you see the map, it's pretty simple, it's straightforward, it's very easy. But for those who have already driven or see the streets in Paris, you know that his way is not, his journey is not going to be as simple as going straight forward, because he's going to face tons of events on his way. Can you go down again? So if you have your driving license, you understand what I mean. If you have ever been inside the city, you also understand what I mean. Because when you drive, you will face tons of situations like a scooter, bikes, pigeons, dogs, people. You will face tons of situations, and no recipe can explain you how to run that. So this is another use case in which the recipe type doesn't work that much. Can you go down again? Computers are idiots. They are very fast, but they are idiots. They don't think for themselves. They follow only instructions. So it's the same thing I just said, is that if you don't give the right set of instruction in the right situation, it won't work. So next slide. So a recipe kind of code wouldn't be enough. Next. Oh. You have to go down again. So the recipe kind of code wouldn't be enough. Can you next? It doesn't take into account the context in which the recipe is applied. And next, and finally, we need another layer of instruction to tell the driver how to react when some events occur. Can you go next again? This is where the highway code, or what you learn during your driving license, comes in. You have another kind of programming, another kind of instruction. It's not just recipe. It's the kind of instruction in which we tell you're told how to react according to situation. So it's not like do this, do this, do this. It's like when you face this situation, this is the rule. When you face this situation, this is the rule. When you face this situation, this is the rule. So this is another kind of programming. Go next. So here we have two ways to write instruction, to write programming, to write instruction for the computer. The first way is the recipe, which is very close to imperative programming. The other way is the rules to handle events, which is very close to reactive programming. So those two words, imperative programming and reactive programming, are called paradigms. So next again. So paradigms, I don't want to take too much time here explaining what it is, because it's not clear even for the most experienced developer. Most of the people, most of the developers have a lot of trouble shifting paradigms. If I had to give a quick definition about what it is, it would be that a paradigm is like a style of thinking, like a way of thinking when you design your code and where you are coding. It means that it's not only about code, it's also about designing the solution. You don't think the same way if you're thinking functional or if you're thinking object-oriented. So paradigms is the way you think, your approach to the issue and to the design of the solution, and also the way you code. So like for everything, different paradigms are well suited for different situations. And most of the developers are stuck with one paradigms, and they have trouble shifting from objects to anything else, or to from I don't know functional to anything else. So most of the developers have troubles to shift paradigms. Can you go on the right, please? So I'm going to discuss reactive programming by example. So next, down. So let's say you have two modules, module A, module B. So and module A has an impact on module B. It means that when module A is updated, module B has to be updated also. So it means that in module A, so you have you have two way to implement this. You have the red way, like you see the red circle, and the blue way. The red way means that module B knows, the red way means that module A knows module B. It means that when you write the business rule for updating the module A, when you write business rule of updating module A, you will have to access to module B to push the update. The blue way means that module B knows module A, and when you write the update, but it means that they are connected somehow. We are going to see it right after that. So next. So here we are going to implement the red way. The red way is when the module A knows the module B. So this is pretty basic. So you have your class, for instance, which is module A class, which has a private attribute, which is module B of type module B. And during the setup or constructor, you have to link your module A object or module to the module B object. And in the update, you have the method to update the module A. In the update, you have to force the update of module B. So go next. And here you have the content of module B. So module B is basically a class with the update, which is public. But notice here we have the same issue as I told, the same as I told when I saw the recipe. I don't know when or why the update would be called. What I know is that I have an update function which is public. It can be called by anything. I don't know how, in which situation the module B is called. It means that this code is not complete. So, and another issue is if I wanted to know how many module depends on module B, has an impact on module B, it's very complicated. I have to search for module B like everywhere. Like if you see the next slide. So in this case, with the code I just showed you, well, you have to search like everywhere to see which module, where is the dependencies between module A and module B and module C, etc., etc. So you go next. So this is another way to implement the dependencies between module A and module B. So here, the update function, the update method is not public anymore. Okay, so module B is the only one to know its business rule. And if you see the setup, the constructor method, you have the module A on update, and you give a callback to the module A. So this is the other way, the blue way, if you remember the first schema, the first diagram. So this is the blue way with callbacks. So callbacks are reactive. This is a more reactive way to implement the dependency between module A and module B. So here, this is a typo here. The constructor should have been module B, not module A. So just go with me here. So here, module B, inside the module B, you have the situation in which the update is applied, and you have the business rule for the update. So by looking the module B, I can fully understand how it works. So this is reactive. And there is another thing about reactive programming, so I will come into it later. But this is a more reactive way to implement a dependency. Next slide. So when you look like module A here, it's a bit different because now you have to manage callbacks. So this is like for those who have already done some JavaScript, some JS code, this is very common. You can have a list of callbacks. It's not only in JavaScript, even in .NET you have that. So here you have to only manage callbacks and trigger the callback when it's needed. Can you go next? Another example, another much simpler example is Excel. When you search on the internet about reactive programming, Excel comes out like a lot because of the way formulas are coded in Excel. It's say that it's reactive because when you look inside a cell, you know which other cell can trigger an update in the cell you're looking. So that is partially why Excel is seen as reactive. And the other thing is the propagation. This is the name. This is one word you need to have to say your code, your module your code is reactive, is how it's propagated. So we are going to see how the propagations work in a reactive code. Can you go next? So streams. So normally the dependencies between two modules in a reactive code is not with callbacks because well, it's a too strong dependencies, so it's not good enough, and the propagation is well more complicated to work with callbacks. So there's another way, is streams. So streams is, if you go next slide, so the definition of stream is a sequence of data made available over time. So it means that it's some kind of object which will hold a list of data. You can push the data at any time. So over time, you can have some data in it, or less, more or less, and you can have consumer who will read the data. So you have two criteria. So it's a sequence of data made available over time. And next criteria, next slide. The items in the stream are processed one at a time. It means that the consumers of the stream will get the items one at a time. It means like whatever, like if you put data in a more chaotic way inside your stream, the output will be sequenced. So one at a time. If you go next. So do you remember the slide with the driver who will face chaos basically in the streets? So if you go next slide, this is how you handle chaos. It means that whatever the events, whatever the situation, the interruption, the interactions, the events are for your computer, for the driver, the best way to handle it when you think reactive programming is to stream is one at a time. Like each consumer will process the events one at a time. Okay. So next slide. This is how we usually represent the events, an event stream. So basically you have a timeline and you have the item, the data inside the stream, which are represented one by one, and you can apply transformation, many stuff. Hopefully, I will be able to share my screen if we want to see that. Next slide. So if we take back our code for the module B earlier, which was working with callback, like you have you have the onUpdate inside the setup call in which you give the callback. This is not actually the true reactive way to write it. So if you go next, this begins to be more reactive. You see the get result method directly is connected to the update stream, to a stream, okay, to the stream, and for each item, the fold function will perform an aggregate uh, by running by processing items by item inside the stream. So for each item, it will call the update. So this is a more reactive way to write it. You see, you don't have any other method, any other thing. You don't have a setup. You pass directly the stream, and it works. So everything is private. So if you go next slide, you only have one method which is public, which get the results with the using the stream, and you can remove the private method with the update, and inside the get results, you know directly which stream we depend on. So you don't need a constructor, you don't need anything else. You already have the full code you need. And if we go further than that, you can come close to functional programming because you remove the idea of state actually in your module. Okay, in your next page. So this presentation, I started thinking about it when I was trying to document one feature for my for user interface we have in my team. So the main question I asked myself is, what is the responsibility of the GUI? It's seems like very simple as a question because most of the people would say, but it's displaying data. But actually, it's more interesting than that. I would like to oversimplify it, but not that much. If we go next, if I ask the same question for the backend to see what I'm expecting, is for every backend module we see, most of the time when we code backend function. Wait. When we code the backend method module, excuse me, uh, we read data, we aggregate it, apply business rule, and then we send it back. If you're doing something else than this, maybe you're working in something too complicated. The complexity of the backend is rarely about what you're doing, it's mostly about how you're doing it. It's mostly about, I don't know, memory, speed, I don't know. But most of the time, the thing we code are that basic. Read data somewhere, aggregate it, apply business rules, and send it somewhere else or send it back. But this is the backend, what the backend do most of the time. If you go next, that allows us to draw this kind of diagram. So this is a diagram of sequence for a feature we have to develop in my team. So you have different module, and it's pretty easy because for each module you can see the pattern. Like we call a module, we get the data, we bring it back, and we can do it for every module. At one point we are going to aggregate it, we are going to apply some business rule, and then we are going to send it somewhere. For each module, this is possible because most of the time the backend is not that complicated. The complexity is sometimes I don't know, reliability, resilience. It's other stuff, but it's not about the business. No, most of the time. If you go next, so I ask the question again. I want to do the same type of diagram for my user interface, I'm not talking about mockups. I want to do like the same diagram but user interface. How can I design a feature on the front? That was my question in the beginning. You go next. So the UI has for objective to display data. Sure. So this is the part where this is a huge part because mockups can be complicated, but this is a huge part. But this is not what is well. It is not my interest right now. My interest would be the next. Uh, the UI responsibility would be to manage a stream of interaction, users, network, browser, computer, etc. Like uh, on the web, sometimes I don't know, you can lose the network. Your UI still have to manage that, to handle that. The user can perform some action you didn't foreseen, so you have to manage that. Like if you're using, but this rule, this responsibility, it's not only for web application, it's also for mobile application. If you have a mobile application, the network is not very reliable. So you have a ton of stuff happening in user interfaces most of the time. So the UI is the jungle. Like anything can happen. If you go next, the summary is the one of the goal of the UI is to manage chaos. Like the UI should manage the chaos. So if you remember what I told you earlier, if you think reactive, but the way to handle chaos is items one at a time. So this is why a library like such as React, Redux, more than React, Redux are so popular today. It's because Redux implements the way of thinking, like it's implemented in a reactive way. This is why it works so much, because it's made to handle uh, events, action, message one at a time. Okay, if you go next. So this is how we designed we finally decided to design a feature on the front. So it's almost like the same graph I showed you earlier with the stream. I wanted before to introduce, of course, RxJS. RxJS is a library like to manage stream, and which is designed to do some reactive programming. So it's a very popular library, even though like almost nobody work directly with RxJS, but many other library depends on RxJS. So here you can see this is on npm trends. So this is like some real data. Like RxJS is more like downloaded than React or other stuff like Angular, Vue, etc., etc. So it's a very used library. It's a very used library, but by other libraries. I'm going to showcase you the library named RxJS I showed you first before. This is a library made to manage streams. So this is a library, the basic, the most common library used to do reactive programming on the web. So you have the equivalent of RxJS in many languages. You have the same library almost on Java, .NET, and other stuff. And so, of course, the JavaScript. So I'm going to showcase how it is used. So this is here. I have my TypeScript project here. So I'm in a project, JS project. So on my package JSON, I've already added RxJS. So here you have the Webpack for bundling and TypeScript, TS loader for transpiling, and you have RxJS. So I'm going to use it. I have an HTML file which have some style here, title, a title here, two button, and a few divs. So here on this div you will have a UL for to put some. The idea here is dynamically we are going to put some items in the list. So list item, we'll see it later. And the same here, we are going to put some data in here. So we'll see. And so my HTML file is related, is linked to, is depending on the bundle.js. So the bundle is here. This is the TypeScript code for the bundle. So I have different version here. I'm not going to use this. So I'm going to work directly from scratch. So this is some live coding. So I'm basically going to first run it. So npm start. Okay, webpack dev server. Okay, so here I normally should be running on ports 8080. I'm going to check. Going to working. I'm going to open Chrome because whoa, tabs. Okay, let's see 8080. So this is the output of my code here. So you have the title, two button, and if you go and you try to inspect, you have basically the same code here. So it's okay. So now I'm going to add some to create some streams from these fronts. I'm going to create stream from. So the idea of ArcGIS is like basically you can create streams from anything. So it can handle events. So here I'm going to create a first stream from this button. So the stream I'm going to work with is wait a second. The button stream. So let's start with the left button stream. I'm going to call it the left button stream. So left stream. Okay. The left stream should come from, okay, so I'm going to import RxJS first. So imports from RxJS. So I'm going to import a function called from event. Okay, the idea here is I can create streams from any kind of event. So remember the stream is a flow of data. So it's a set of data made available over time. So this will help me create stream. So from the click, I'm going to do on my button. So here I'm going to use the function. Not the right one. From even. Okay, again. From even, and I'm going to get the button. Documents. Get element by ID. So I'm going to come back here. Okay, and I'm going to, so this is already the good errand. So here I'm going to say, okay, I want to create event from the click. So here I have created my event. So I prefer, I can like the simple code. So I created my my event stream, so nameless stream. So here I can directly subscribe to this event. So left stream dot subscribe and do something with it. So I'm going to write. So here in my events, so, okay, I'm going to get inner HTML plus equal. So inner HTML of which one? This one, the lists. here, rules, click on left. Okay, so normally here, this is the most basic usage I can do from RxJS. So here normally should be working now. If I do something like this, I have to refresh the page, I guess. I think I forgot something. Wait. Left stream, subscribe. Pipe from event. No. What is the issue here? Left stream, left stream. So let us, we're going to debug it. Index.ts. Okay. I think I didn't use the right. Oh, I know. The issue is this. Okay, now it's better. So now if I click here, you can see directly my items written here. So I'm going to put some list items a bit cleaner. Okay, much better. So the thing is, what I've told you, the main idea from the presentation I've made is that the front is made to work with chaos, with chaotic events. So it means that you should be able to stream from many types of events, many different kind of events, and the front should be able to handle it. So the best way to try it. So I'm going to add another stream. So of course it would be the right stream event. Here and here. It's okay. So here, I can do, there's two ways I can work with this. So I can directly connect to the item here, directly subscribe to the right stream, and then click on write, of course. This is the first way to work with that. If I click on right, click on left. But there is also some other ways. So for instance, and I'm going to keep with this way. So what I've told you is that most of the time, and this is how Redux, for instance, work, and many other libraries, most of the time, when you work with in reactive style of programming, you don't have like tons of wait up. You don't have tons of subscribers to the events. You try to centralize some part of your application. So here, I'm going to simplify it by creating only one stream. So I'm going to call it the main stream, which will be a merge of my left stream and my right stream. So this is a function that will merge every event coming from any other streams. So I can put any stream in here, and every event inside every stream will be handled, will pass through the main stream, and will be handled as such. So as if there was only one stream. So the merge, if you see when I wrote it, it comes from RxJS. It's a very special function. So I'm going to use it here, main stream. and then I'm going to click here. So click on left, click on left. So my first issue here is if I, like if you see, if I work with that, I won't be able to differentiate. Okay, there is a way to check the content of my event. This is a dumb event, like a click button event. So I won't be able to differentiate the item like easily. So there is a way to transform every event to a new objects, which will be easier for me to work with. So I'm going to use function. So there are some kind of function. So if you have already done some JavaScript, you should already know the function name map, which is used most of the time with arrays, and actually is on your arrays. And you can apply the same type of the same type of behavior on streams. So here, for instance, I don't directly call my map, I can pipe, and here I can apply many functions. So we are going to see map first, and we will see some other function later. So for instance, here I can take any event of my stream, and I will return an event with the type left. Okay, so just to be clear before, so you can see here in my mainstream, you are going to check the contents of the event here. So every item inside the stream will look like this. Log. Okay, so easy, very easy. So if I write it here, okay, so here, this is a mouse event. Like it's basically very complicated to see the difference. It's of course it's clearly possible. I don't know. You have the SRC elements. I don't know. So it's very complicated. I'm going to change it. So here this is what I was going to do. So I'm going to change it. So for instance, I've only changed the items coming from the left button. And when I click here, you see the event is of type left. And when I click here, you have the same basic event before. So here I'm going to use the same kind of function of transformation to apply here on the right stream. And I'm going to change my type. Okay. And then it's way easier now to differentiate which click I'm working with. So now I'm able to differentiate it. So here I'm going to use, okay, either type. Okay, so now it's way better. Left, click on right, etc., etc. So this is not chaotic enough because this is very easy. It's very sequential. I'm going to add something else. So a a bit more complicated event to handle. So I'm going to add another type of event. So here, I don't like that. Okay, mouse moving event. Mouse move stream for events. So here is, I will take mouse move is on the document, and I think this is how it's called. Okay, and the type here is moving mouse. I don't know. Okay, so I can here, by anticipation, I know this will be an issue. This might be an issue. So if my event is not is a type of right, I can write it like this, or I can write it like that. So again, I'm going to check the original event first, and I can add my mouse move events in my stream, my main stream. Okay, so pretty clear. So here I can work with that. Oh, he can't see. He can't see. Oh yeah, sure. I don't know why I write like that. Okay, not better. Wait a bit. Think, think. All right. Okay, let's move from events. Wait, document, move mouse. Yeah, no, mouse move. Okay. Tag. So this will be much better. Should be much better. Okay. Now, if I refresh my page, you see every time I move my mouse, you see tons of events like here. Okay. This is a lot of stuff to handle, to process. So, the time is a very important dimension with streams. So, there is ways to work with time. Okay. So, here I have an event which occurs too many times. It's too recurrent. Like now, I would like to reduce the number of occurrence of my events. So the mouse move event, I don't want to handle that. So first, there is another kind of function I can use here. Okay, the function I'm going to use would be which one? Throttle. Throttle is a function used to, you will see. So it's like the map function, in terms of definition signature, but so you call throttle here, and then it take, you have the callback which will take the event, okay, normally. Actually, you can add whatever you want to do, but the duration selector, I think I can say interval directly and say this. Um, tac. Yes, I have to add interval. Okay. So here I've used my throttle function. So what is the idea? Throttle is like a filter function, but using your events and the current time, the date time like now, as a parameter. The thing is, it won't take more than one event in during 1 second. So in the interval of 1 second, you only will have one event. So the thing is, once I've written this, you see, I can move however I want. You will see only one event per second. Okay? This is the idea of the throttle function. It's like a filter function, but taking also the time, the current date, the time that now, I don't know, the get date, I don't know which language you use, but it takes your event as an input and the current time, and it filter the event from the streams. So you can use it here, you can use it here. It's the same. This is very useful, for instance, when you're writing, you go on Google and you see the inputs which will send search requests for each time you write. If you have somebody who writes too fast, you put a throttle, for instance. So this is an example of how the front is used to manage chaos. So if you have somebody, some user for any reason, which is sending you too much interaction, you can filter it. So this is an example on how you manage chaos. So here I have my event. Okay, I can throttle them. I can also add mapping, so I can transform my event. So I'm going to take this, and I will say, okay, the type of my event now. I don't know, I'm going to simplify it. Mouse. Okay, pretty basic. Okay, so now every time I move, you see only 1 event per second. I'm going to complexify it a bit. So here I'm going to add x equals, no, x, y, net, dot y. So here, okay. Now it should be better right now. If I move, I can see, the coordinates of my mouse moving. And what I'm going to do here is same as that. If my event is mouse, okay, I'm going to write here. Okay, and I think cleanest way to write a span. Yeah, so it could be a bit like pretty. Top. I'm going to put something in here, and the left, I'm going to put something in here. Because, okay, top position, dots, x, yeah, sure. So typing is not a topic for this presentation, so not going to work on it. .y. Okay, so normally I need this, and this is better. Okay, so I think I reversed. Yeah, I reversed the ID. So here you have some dots appearing every time I'm moving, because for each event, for each mouse move event, I have put some span elements inside my mouse cursor, which is the empty div at the beginning. So here, every time I move, you see something. So the idea here is I can handle at the same time a lot of different interaction. You see, okay, it's very complicated. So yeah, I can see a lot of interaction. I can handle a lot of interaction one by one. Like here, I'm having actually at the beginning when I'm moving, a lot of events are happening, and by filtering them, mapping them, transforming them, I can do something like this. So the the best way, most of the time, the best way to work uh, reactive programming is not actually directly like this. Okay, it would be much more like what we do. So I'm not going to type the entire code. I'm going to copy paste another code which looks a lot like what I'm working on like right now. This is so here. Okay, so we are going to study this code a bit. So what is the idea here? So what work here? So the idea here is whenever my subscribe happens, so mainstream subscribe here, I have two subscriptions, so I can add actually two subscriptions. So this one is for logging, this one is to change to affect my state. So the idea of the state is I have a global state first. So this is what happened in most of the application on the front today. When you work on React, when you work with something else, you mostly the best way, in my opinion, to work with it is to work with the global states. Okay, the global state would be this one here. You have clicks and you have position. Every time something happen, the global state is updated through a function taking the input event and the state. This is what, depending on what you say, the technology, the application, the library you work with, is called either a reducer, either update. You know, in for those who work with Elm, this is an update, and for those who work with Redux, this is the reducer. Okay, so this is basically the same thing. So this is the code, like case right, you do something. Okay, in case we add something, we click on something, we are going to add an item inside the clicks array, and the same for the position. So here you have this helps you doing some stuff like some nice stuff. For instance, here my move. This is basically the equivalent of what I was writing before. So here, you know, when I am moving, I have every dot still here, so drawings here. But if I works with something like this, I can do this. Like for instance, positions, I can add a limitation on what I'm drawing, and on the front, you will see how it works. Wait a second. Yes, on the front, you can see how it works. So just by adding here slicing, like just a way to display, I say I just want to display the first 20 elements. This is how it works. So here I have worked with a basic like reactive application. I've created a basic reactive application with 3 types of event. So you notice that if you want to recreate Redux, it's not that complicated. You know, you have to add so some streams. Okay, you have to put in the same stream that is basically conceptually how things work, and then you can use a reducer. You use a reducer to update a global state, and the view is basically a side effect after updating your global state. Okay, this is very simple. So this is basically how Redux work. Okay, and React is much smarter than that, because you know here when I reset the view, I have to recreate the entire thing. So I have to remake every time I add one click. I have to recreate the entire string to put it before putting it inside the inner HTML. So most of them use what we call a virtual DOM. So this is another topic to prevent updating. the full DOM. So when there is an update needed. But the idea is, okay, I've subscribed, and when an event occurs, it will have an effect of on my states. So here, this is the effect. It takes an event as an input, and then it updates the state. Okay, here, this is the 2 lines, and then I can reset my view. So basic. And the reset the view is basically what we call a side effect. So this is much more functional way to see stuff. So this is the side effect. And here you have a pure function, but this is what we are going to, we might talk someday when, if I do something about functional programming. So this is much more what we call a pure function. Why do we call that a pure function? Because every time you put something like for the same parameters, it will always return the same results, and it won't affect anything outside what is inside the function. So for instance, here I take my state, my action, I send it an action, event, message, whatever you want to call that. So I take my state as an input, my action as an input, and then I return a new state. I haven't affected anything outside the function. So this is a pure function. So basically, and reset the view is the effect because I'm going to affect the document. So this is a side effect. And so basically, the idea with reactive programming is like handling chaos. This is the main idea because the front is a jungle. So many things can happen in the front. So we handle stuff by working with them one by one. And we have effect on the view. Having effect on the view is the last part to do. And for those who would ask if I should have tons of events, because here I only have 3 types of events. Most of the time when you work with a GUI user interface, when you are developing your user interface, if it's getting too big, you have to split it in sub interfaces. So the idea is to have this mechanism, but in a smaller case, and the same mechanism in a bigger case, in a bigger scale. Okay. So thank you, and I hope the presentation wasn't too complicated to follow. After that, it's the end.